Good evening, students. Today we are going to learn about iron-carbon equilibrium diagram. This is the second part of the type of steels. In the previous webinar, we have studied about what are the types of steels, what is the difference between steel and cast iron, how the steel will convert according to the percentage of carbon we have studied in the previous webinar. In this webinar, we are going to see the different microstructure of steel and cast iron according to the different temperatures. When the steel or cast iron is heating or under the heat treatment, how the structures will be changed according to the temperature. That we are going to see through this iron-carbon equilibrium diagram. So before going to enter the iron-carbon equilibrium diagram, we should know what is meant by phase diagram. The phase diagram is the graph which will represent the composition of steels as a function of temperature. So phase diagram is the basic diagram which will indicate the different types of structures of different composition of carbon according to the different temperatures. Before going to enter the iron-carbon equilibrium diagram, we will see about the cooling curve for pure iron. So when the pure iron is heating above 1600 degrees Celsius, it will be in the liquid stage. After getting the liquid stage, when you are cooling slowly or curing slowly, the pure iron will get different phases. When the temperature will reaches from 1600 degrees Celsius to 1538 degrees Celsius, it will be converted from liquid to delta iron stage. Delta iron is in the form of basic cubic structure. When the temperature will get 1394 degrees Celsius, the delta iron will be converted into gamma iron. So gamma iron is a phase cubic crystal structure. After that, when the temperature will reaches to 912 degrees Celsius, the gamma ion will be converted into alpha ion. The alpha ion is in the form of basic cubic structure. So when we are heating the temperature, heating the steel up to 1600 degrees Celsius and slowly cooling, the steel or cast iron will be getting different microstructures. That is the basic concept of iron-carbon equilibrium diagram. Now we are going to see the iron-carbon equilibrium diagram. So the iron-carbon equilibrium diagram will consist of the steel from the carbon percentage of 2 to 6.67 percentage. Carbon percentage from 0.02 percentage to 6.67 percentage. As we know about the steel types from 0.025 to 0.6, that is low carbon steel, from 0.6 to 0.8, that is medium carbon steel, then 0.8 to 1.2 percentage, that is high carbon steel. After 0.8 to 2 percentage, it is a high carbon steel. After 2 percentage to 6.67 percentage, it will be cast iron. So now we are going to see different phase structure of plain carbon steel as well as cast iron. So this is the diagram of iron carbon equilibrium. This diagram will indicate the different phase structure of steel as well as carbon. So if we are starting from 0 to 2, this is the steel. Then 2 to 6.67, this is cast iron. So now first we are going to see about the different phase structures of steel. So when the temperature reaches 1500 degrees Celsius, as I told, it will be in the liquid stage. After that, it will be getting different stages. So from 1600 degrees Celsius, the liquid stage will be converted into liquid plus delta ion. Then the temperature will be slowly decreasing. The different structures will be obtained. First of all, it will obtain the structure of austenite. So this is the austenite stage. This is the austenite stage. Uh, After the temperature will be slowly fall on, the temperature will be at the temperature will be 1670 degrees Celsius, or sorry, 1670 degree Fahrenheit, or 910 degrees Celsius. The austenite will be converted into Pierite plus Ferrite, or Pierite plus Cementite. So the Pierite plus Ferrite in the case of low carbon steel or medium carbon steel, Pierite plus Cementite in the case of high carbon steel. So this is the different phase structures of steel. When we are moving into cast iron, first of all, when the temperature will be reaches 1600 degrees Celsius, as in the case of steel, it will be in the liquid stage. When the temperature will be slowly decreasing, when the temperature will reaches at 1147 degrees Celsius, that is the high critical temperature. So when the high critical temperature will be obtained, the liquid stage will be converted into gamma plus liquid and liquid plus ferrous carbide. When the temperature will be decreasing below 1147 degrees Celsius, two structures will be obtained, that is austenite plus cementite plus ladybird. In the case of uh, hypoeutectoid steel, hypoeutectic cast iron, so the cementite plus ladybird structure will be obtained in the hypereutectic cast iron. So when the temperature will reaches at 723 degrees Celsius, that is the low critical temperature. When the temperature will be getting low critical temperature, that is 723 degrees Celsius, the phase structure will be converted into cementite plus pierite plus transformed ladybird. So this is the different phase structures of cast iron. So once again, I am repeating, up to 2%, the different phase structures of steel. From 2% to 6.67%, the different phase structures of cast iron will be obtained. Now we are going to see three types of reactions. So first one is, so this is the, so before entering the different types of reactions, we must know about the different types of steels in the case of iron carbon equilibrium diagram. So 0 to 0.8% of carbon, that steel is known as hypoeutectoid steel. From 0.8% to 2% of carbon in the iron, that is hypereutectoid steel. From 2% to 4.3% of carbon in cast iron, that is hypoeutectic cast iron. From 4.3% to 6.67% of cast iron, it is known as hypereutectic cast iron. So this is the basic concepts of iron carbon equilibrium diagram. So once again I am repeating, 1130 degrees Celsius is the high critical temperature, 723 degrees Celsius is the low critical temperature. And also, there are three types of reactions will be there. First one is eutectic reaction, then eutectoid reaction, before that peritectic reaction. So that reactions we are going to see next. So different types of reactions are indicated in this diagram. First one is high eutectic reaction. This is the eutectic reaction. What is meant by eutectic reaction? Eutectic reaction means when the liquid will be converted into one solid and one liquid phase, that is known as eutectic reaction. So in this condition, when the temperature will be reaching 1447 degrees Celsius, the liquid phase will be converted into liquid plus gamma, austenite, and liquid plus ferrous carbide. So this is known as eutectic reaction. Now we are going to see peritectic reaction. This is the peritectic reaction at the temperature of 1493 degrees Celsius. So when the steel is solidifying at temperature of 1493 degrees Celsius, the liquid stage will be converted into liquid, and gamma will be converted into liquid and alpha, liquid and delta will be converted into gamma. So this type of reaction is known as peritectic reaction. Third reaction is known as eutectoid reaction. So this is the eutectoid reaction. In the eutectoid reaction, the gamma austenite will be converted into alpha ferrite and ferrous carbide, that is cementite. So this status is known as eutectoid reaction. These eutectoid reactions will be done at the temperature of 723 degrees Celsius, that is low critical temperature. So these are all the different types of reactions. So first one is peritectic reaction. Peritectic reaction will be held at 1493 degree 95 degrees Celsius, and the carbon percentage of 0.18 in the ion. That will be the addition of delta ferrite plus liquid will be converted into gamma ion austenite. That is peritectic reaction. This will be done in the case of low carbon steel. Eutectic reactions will be held in the cast iron, that is 4.3% of carbon in the iron at the temperature of 1147 degrees Celsius. So in this temperature, a liquid of cast iron will be converted into two stages, that is gamma ion, that is gamma austenite, plus ferrous carbide, that is cementite. Third reaction is eutectoid reaction. It will be held at the temperature of 727 degrees Celsius and 0.77% of carbon, that is medium carbon steel. So eutectoid reactions will be done in the medium carbon steel at the temperature of 727 degrees Celsius. That is, gamma ion will be converted into alpha ferrite plus cementite or pierite. So these are all the three types of reactions. Now we are going to see about the different structures we have studied from the iron carbon equilibrium diagram. First one is austenite. Austenite is the gamma ion, that is interstitial solid solution. It will be the austenite will be done at the temperature of 1130 degrees Celsius in the case of steel. So it is normally not stable at room temperature, but under certain conditions, it is possible to obtain austenite at room temperature. So this is the austenite structure. Then second one is ferrite structure. Ferrite structure is also known as alpha ferrite. alpha ferrite or alpha solid solution. It is in the form of BCC structure. It will be happened at temperature of 912 degrees Celsius. This ferrite will be obtained maximum in the case of low carbon steel at the temperature of 723 degrees Celsius. This is in the form of ferrite. So this is the ferrite form of structure. Then next one is Pierite. Pierite is a type of steel structure that is low, medium carbon steel structure will be held at the temperature of 723 degrees Celsius. It is in the form of this black type of flakes. Next one is that is Pierite. So Pierite also, as I told in earlier, it will be done at the 723 degrees Celsius in the composition of 0.8% of carbon on slow cooling. So this is the Pierite structure. Then Cementite. Cementite structure will be held at the temperature of 1140 degrees Celsius in the case of cast iron. That is 6.67% of carbon in the iron. So this is very hard and brittle because cast iron is the brittle structure. So cementite is a very hard and brittle structure. It is also known as ferrous carbide, that is Fe3C. So this is the ferrite structure form. Cementite structure form. Next, last one is Ladybird. Ladybird is the eutectic mixture of austenite and cementite in the case of cast iron. That is 4.3% of carbon. It is formed at 1130 degrees Celsius. So these are all the different types of structures of steel and cast iron from the iron carbon equilibrium diagram. So far we have studied about the different types of steels and different types of cast irons through the iron carbon equilibrium diagram, and also different type of reactions, that is eutectic reaction, peritectic reaction, eutectoid reactions. Finally, we have studied about the different types of structures of steel and cast iron from the iron carbon equilibrium diagram. So I hope that we have well known about the iron carbon equilibrium diagram, and also what are all the different types of steels and different types of cast irons when the iron with carbon percentage, different types of carbon percentage will be heated and slowly cooling. Thank you so much.
Thank you so much for watching the video. Make sure you've subscribed so that you can get the regular updates. Use the feedback ink in the description to get your certificate. Thank you.